Hello everyone, welcome back to a new and fresh video. In this particular video we are going to discuss about the exponential distribution. So what is exponential distribution trying to measure? Actually we can say typically we use exponential distribution when we are measuring the time interval, right? When we are measuring the time interval between events and a Poisson process, between events in a Poisson process. Actually in the previous video I had discussed about the Poisson process, Poisson distribution, talked about Poisson process. If you have not watched it, then you can watch the video, link will be in the description. So actually what does this mean? So in Poisson we had seen an example. We were trying to measure time between consumers were coming to the Amul cafe, right? So imagine let's say this is my time axis. This is my time axis. Let's say this is my event. Let's say this is my event, right? This is event. So they I'm just telling like this. These all are events happening, right, on this time. So each of these visitors, or let's say each of these customers who are coming to the Mool cafe, right, in this whole time. So now assume, let's say assume this is your 1 hour. This is your 1 hour. So actually this is 1 hour, means like say 1 unit of time is here is 1 hour. So how many events have happened in this duration? There are 4 events. The number of events are 4, right? So if you want to measure the number of events per unit time, we use the Poisson distribution. I am again repeating. If we want to measure the number of events per unit time, we use the Poisson distribution. And if you want to measure the difference in time interval, then you need to study the exponential distribution. Let's say this is nothing but your delta t1. I'm talking about the time. Let's say there is a delta t, right? Delta t, this is nothing but your time. So let's say this is your time difference between the two events, which is delta t1, and this is the time difference, which is delta t2, right? This is the time difference, let's say delta t3, right? And this is the time difference, which is delta t4, right? So precisely I can say studying time interval between these events use exponential distribution. So if you are trying to study time difference as people coming to Amul cafe, in such a case use exponential distribution. There are something a strong connection between Poisson and exponential distribution. If you have a Poisson process, what does this, like say number of events per unit time, number of events per unit time, and the per unit time follows Poisson distributions, and the time difference between these events follow exponential distribution. Okay, so Poisson process is like if you have events happening at constant rate lambda, where events are independent and not two simultaneous events are occurring. So this is your ideal Poisson process. This is your ideal Poisson process, right? So exponential distribution is like a continuous random variable distribution, because see here time is continuous value, right? Time is your continuous value. So you can get here probability density function and cumulative density function, which we call it PDF and CDF in the exponential distribution. So actually there is one more property in the exponential distribution which we talk about, the memory less property. Memory less property. So what is that memory less property? What matters is only when the previous event occur, only from that time it looks when next happens. Let's say, yeah. So here in this, what will happen? Okay, if it follows, like it's matter only when the previous events happen, right, occur, and only from this, only from here, that time it looks the next happens, right? This is your Poisson's, right? So when I tell this is nothing but your time, which was your previous, and this was your next. So it doesn't care about when the earlier events happen, right? Doesn't care about that. It doesn't care about when the earlier events happen. This only matter is this. Okay, so the exponential distribution is only measuring the time interval from the previous event to the next event, right? So its PDF will be lambda to the power minus lambda x, right? And mu average is nothing but 1 by lambda, and its CDF is nothing but 1 minus e to the power minus x by mu. This is its CDF, right? Let's talk about more about thing. Let's say I am taking the value, let's say I am taking something value of this lambda. Let's say I have taken lambda is nothing but 5 and mu is nothing but 1 by lambda, right? I have taken. So actually what is that? Okay, what is the probability that an event happening in next x minutes? I want to find what is the probability that an event will happening in the next x minutes. So let's say this is given as nothing but p of x lambda e to the power minus lambda x, or you can write it as lambda e to the power minus x by mu, because I had seen here this mu is equal to 1 by lambda. Okay, so we can write as like this. So what is this? This is nothing but, this x is nothing but your time period. This is your time period. So actually having probability of a customer coming in next 10 minutes, let's say probability of a customer coming in next 5 minutes, probability of a customer coming next 8 minutes, right? This is the thing, right? So here x is nothing but your what? Probability of an event happening in next minutes. Let's say I take the example 10 minutes, 8 minutes, 5 minutes, right? It is all the way from now. Actually it is all the way from now, right, to next 10 minutes, which I am talking about. Okay, so what is, let's convert this. Mu is nothing but 1 by 5, which will become 0.2. Let's convert it into minute. Let's say convert, then it will become nothing but 12 minutes. Okay, 12 minutes. So on an average, for every 12 minutes, a customer is coming to the Mool Cafe. Right? So mu is what? This is nothing but the average time between the events. Average time between the events. So what we did find from this 12, this is telling that on an average, for every 12 minutes a customer coming to a Mool Cafe. So let's say one more thing. Okay, what is the probability that a customer will come in next 10 minutes? See, so x is what? X is a time period in exponential. X is a time period in exponential, right? So let's find out, let's say CDF, probability of x less than 10 minutes, right? this is nothing but this will be the probability of an event happening in less than 10 minutes, right? So we have given lambda is equal to 5. Actually find out the mu, nothing but 1 by 5, which was 60 by 5 converted into minute. This was the 12 minute, right? This was the average time per event. So we can say given the average time per event, what is the probability of that event happening in less than 10 minutes? So this will be like this: x is less than 10, so we can put 1 minus on the formula, that is what, 10 by 12, right? It will become 1 minus x exponent minus 5 by 6, which will calculate something called 0.5. it will come, right? 5655, whatever consider. Now this is the thing. Let's say I take in probability x greater than 30 minutes. What will happen? So it will become 1 minus xp of minus 30 by 12, right? So it will become 0 plus, yeah, minus 30 by 12, nothing but you will come 0.08, right? This will come. So what's happening here? Let's say now look at these two probabilities. Right? Observe it. So when the average time per event is 12 minutes, right? The probability of an event happening in less than 10 minutes is 0.5. So whereas for greater than 30 minutes, that is 0.08. So when we say probability of an event happening greater than 30 minutes, so see, when we say like probability of an event happening greater than 30 minutes, we are assuming here that the event had not happened yet. In the first 30 minutes, event didn't happen. Now think of, if an average, right, one event happening at every 12 minutes, for the first 30 minutes no event happening at all, should be less, right? See, if at every 12 minutes for the first at every 12 minutes an average and event is happening, and for the first 30 minutes no event happening at all, right? But there is still some chance, there is 8% chance that the probability of something not happening in first 30 minutes is 8%, right? So this was overall about the Poisson exponential distribution, right? So you can relate Poisson and exponential distribution. Actually Poisson is a discrete and exponential is a let's say what, this is a continuum, right? So you can correlate each other and you can study about this Poisson and exponential distribution. Thanks for watching this video. We will see the next distribution in the next video.